So today we are solving this problem, most profitable path in a tree. So let's read the question first because there are a lot of conditions itself. So first of all, there is a undirected tree with n nodes level from 0 to n minus 1. So starting from 0 till n minus 1, every root has certain index value. So you are given a 2D integer array edge of length n minus 1 where edge I equal to ai bi, means from ai to bi we have an edge, indicates as an as simple, right? So at every node I there is a gate. So you are given an array of even integer amount where amount I represents the price needed to open that gate. Okay, so there are certain conditions. The cash reward obtain an opening gate at node I. So there could be an amount, it could be a negative value as well as positive value. Okay, so there are two person, Alice and Bob. So you can visualize here like this. So suppose this Alice is always standing on the very first node. Okay, you can call it, let me call it A. So this is Alice. Alice is always starting from very first node, basically the zeroth node, root node. And Bob could be anywhere. For example, let's say Bob's initial position is at here. This guy is Bob. Now the thing is, the intention of Bob is always to move towards the root node. Okay, so Bob will always try to reach to the root node, where in this case zeroth node. And the Alice has the tendency to reach to any of the leaf node. So obviously Alice would try to go downwards and Bob would be try to go upward to reach at the root node. That is the first criteria. Now next thing is, whenever they are reaching at any node, this is the array. Okay, so at every index, whatever index is the node, this is the cost, basically the amount needed to open the node. Now there are certain conditions, so we will read it. So see here, initially Alice is at node 0 as we already discussed, and Bob could be at any node. So at every second, Alice and Bob each move to an adjacent node, right? They can move to by adjacent only. They cannot jump to uh, more than one. They have only one choice to reach to any adjacent node. Okay. So as I told you, Alice moved towards the leaf node and Bob moves towards the node 0, which is we can call root node as well. So for every node along their path, Alice and Bob either spend money to open the gate at that node or accept the reward. So basically what does it mean is, we are given an amount array like this. So for example, Alice is at 0th node, right? So she has this minus 2 amount. So minus 2 means it is not reward but it is spending. So we don't have to bother whether it is negative or positive. Anyway, that much amount would be taken as a reward. In this case, it is to spend. If it is positive, then it would be an reward. Okay, then we will read to the next point. So if Alice and Bob reach the node simultaneously. So one more thing is, if the gate is already open in the sense, if let's say Bob is moving from here from 3 to 1, that means gate number 3 is already open. So in this case, if Alice comes in this way, by any chance if Alice reach here at 3, so 3 is already open. In that case, she will not get any amount because it's already open. So no reward, no spend. So we have to keep track of who is open, who is not. And another point, if both of them are reaching at the same time together, for example, Alice make a step from here to 1 and at the same time Bob also making a step to reach this node 1. So they are reaching simultaneously. So if they are reaching simultaneously, they have to divide the amount. For example, at node 1 the amount is 4, right? So what will they will all of both of them get? 4 by 2, whatever it is, it would be divided by 2. So 2 would be the amount that would be divided between Alice and Bob because they are reaching together. So this is another scenario. See here, if Alice and Bob reach simultaneously, they share price reward divided by 2, right? Both of them. So this is the another. So now next point is, if Alice reach a leaf node, she stops moving because Alice target is to reach till any leaf node. For example, if she comes 0 to 1 and 1 to 2, then 2 is the leaf node. She wouldn't move anywhere, right? So this is the another condition. But what we have to do basically is, return the maximum net income Alice can have if she travel towards the optimal leaf node. Okay, so now Alice can go to 2 or 3 or 4, 2 or 4, 2 and 4 are the leaf nodes, but we have to find a such a way that Alice has the maximum amount of award. Now at the same time, Bob is also trying to go upward. So Bob would be opening certain nodes, and if gates are open, then there would be no award point would be awarded. So we have to find that combination which will give the Alice to reach any of the leaf node, including Bob is moving to the top of it. So we have to find the maximum amount Alice can acquire. So this is what we have to do. It's not only to reach a leaf node, but to reach a leaf node with the maximum amount of the award. This is what we have to do. Now next thing is, what would be the approach? What is the approach here? So as we know that we are starting from Alice downwards and from Bob to upward, we can have a DFS approach, that also a single DFS, depth first search. Okay, we are not doing 2 times traversal of the nodes. Okay, so how we can do that? So to do that, what we can do is, we can have a variable called time. Let's say we have a variable called time t. Okay, so this time t basically indicate that the reaching time of Alice at any node. Okay, now at the same time we will do one more thing, that from Bob we will have an array which will give us the distance from the Bob for any node. Okay, so in this case, let's say if Bob could be any node, right? Alice is always starting from 0, but Bob could be anywhere. It could be 0 as well. Okay, so we will create an array of size n, basically whatever the number of nodes, that would be the size, and we will create an array. This array is basically indicate to the distance from Bob. In this case, Bob is 3, right? So let's say we will make it 0, 1, 2 and 3. So what is the distance of 0 from Bob? It is 1 and 2. So it would be distance 2. What is the distance of 1 from Bob? Bob is at 3, so from 1 it is 1. What is the distance of 2 from Bob? It is 2. What is the distance of 3 from Bob? It is 0, because 3 itself is the Bob. So this array would be, we will keep with us. Now why do we need this array? Because we need to keep track that who reached when. Because Alice, this time, okay, this time t, let's say I'm calling it time. This time variable is basically keep track that Alice, when Alice reached, whether she reached when Bob also reached. So now you can consider one thing, that every movement, this time is a unit, right? So in this case, let's say 1. At node 1, the distance of Bob is 1. And similarly, if Alice makes a move here, it will take the 1 unit of time, right? So distance of this node from Bob is 1, and also the time taken by Alice to reach this node is also 1. In this case, what will happen? Both of them are reaching simultaneously. So if time equal to the Bob's distance, in that case what we have to do? We have to divide this amount divided by 2. So let's take an example that how this, in this case, what will happen. Okay, so in this case, when 3 moves to 1, okay, and this time Alice moves to also 1. So what we will do here, at opening at 0, what would be, what amount Alice would have got? It is -2. Okay, so let's take -2. Okay, now Alice came here at 1, but at the same time Bob also reached at 1, and we know that when they are reaching simultaneously, they have to basically divide the amount equally among them. So it would be what? For Alice, let's say I'm calling it A. So for Alice, it was -2 at 0 gate, right? And 4 divided by 2 at 1 gate, because it is reaching simultaneously. So 4 divided by 2. So what would be the total? Alice so far till reaching, she had 0 award, right? -2 and +2. Now similarly, Bob came here at 1. Okay, so Bob, what amount Bob would have been? So 3 is already open now, because Bob is already open. Bob is starting at 3. So gate number 3 is now open. So at 3, So now what will happen? Alice would be coming from node 1 to, let's say, 3. But at 3 she would have got this -4, but because 3 is already open, so as we know, if in case of open, we don't get any amount, right? We don't spend, neither we get. So 3 would be now here at point 0. Now Alice would come here at 4. And what is the amount at 4? At 4 it is yeah, here is the amount. So at 4 it is 6, right? So we will add 0 plus 6. So what is the Alice total reward? Alice got total 6 amount. So to reach at the leaf 4, but at the same time Alice could have come to the node leaf 2 as well, right? So let's say if she is coming till 1 she spent 0, but thereafter she came here. So at 2 what she will go? She will get 2. So if she chosen to go to this leaf node, she would have got only amount 2. But we are looking for the maximum, so we cannot go for this value. 6 would be the greater value, we need the maximum value. So this is what we have to do. Okay, now next thing is how to do this. Okay, so we will show what would be our approach. Similar idea, whatever we discussed, same idea we would do. What we will do is, first of all, we will write the bob distance array, and then we will write a method. There we will have the start point, and we will have the this guy, the bob point. Okay, bob is nothing, just a point where bob guy is starting. Okay, so now I will show you how we have done this. So let me show you my code, and I will explain each and every line with the proper reasoning that why I have written that code. Okay, so see here. First of all, what we are doing is, this is my class solution, right? So first of all, I have created this adjacency list just to make this graph, right? We do in our graph. A tree is also a graph, undirected graph, right? So this is the adjacency list. This is the array distance from Bob. We were just discussing, right? Just like this. This is the distance from Bob array. So that array I have created, and this is just the size and n. Now see what we are doing is, first of all we are initializing adjacence to array list, and the whatever amount dot length equal to n. Now see here, this is our distance from Bob. Initially we have put n here. Now what we are doing here, you can see this for loop. In this for loop we are just initializing the adjacency with the new array list. Basically every node, n node, we are first of all putting the array list, right? Because this is a list of lists. Now what we are doing here, in adjacency we are given this as, right? So as has the two values. Okay, so we are making this adjacency list, and because this is an undirected graph, and so in undirected graph, if a to b is a, if a to b there is an edge, then b to a is also an edge. That is why I am taking the both values and adding into the adjacency list. Okay, now our adjacency list is also completed. Okay, now what we are doing is, basically we are writing one utility method. Okay, and this utility method, what it is doing, util method, basically this first parameter is src. Basically this is the point where Alice is starting, so this basically this is 0th node initially, and parent is the parent of this src. So initially this parent would be no parent, right? So we will pass 0, and time is the unit way when Alice is started, and Bob is the point where Bob has been assigned, and amount is the given array. So see what we are doing is, first of all we have created two variable, max income and max child. Why this is max child? Because this is to anchor for the whether if it is a leaf node or not. So initially we are starting with the min value into it, and now see here, if src equal to Bob, basically when the point where Bob is starting is also the src where Alice is starting. If that is the case, in that case what will happen? Distance from Bob of src would be obviously 0. Otherwise we are putting default value n initially, because which is the largest value. But anyway, in the code we will handle how to get the minimum value distance from the Bob to any node. Okay, so see here, we are getting the adjacency list, all the nodes in the src, right? All those nodes which are directly connected to the src point. For example, in this case 0 is connected directly to 1. So it zeros SRC, only 1 would be there. So same way we are doing there. So we are going through the adjacency nodes, and if node is not equal to parent, because this is an undirected graph, so in the adjacency list parent also would be there, and we don't want to go back to the parent, right? So for that reason we are putting this condition. And see here, for this max child, what we are doing is we are getting the maximum value of it. So what we are doing, max child is math.max of max child, and util we are calling on this node. So this time now we are moving this node downwards. For example, from 0 to 1 we came at 1. Okay, so same way we are doing. So for this node we are calling it now, this is node, and SRC would be the parent of it. The one which was initially SRC, now it is the parent of this node, because this node is coming from the adjacency list of SRC. So now parent, in place of parent we moved SRC. Now time equal to time plus 1, because we are moving 1 point, right? So if we are here at t, then t plus 1 at 1, because 1 unit of time we are moving. So same way we are doing this time plus 1, and bob and amount are the variable that are given. Now see here, we are also updating the distance from bob for every point. So here distance from bob SRC equal to math.min of math.min, because we are looking for the minimum value for every node. So we are calling the distance from bob SRC and distance from bob node plus 1, right? Because we are moving downwards. So this node, at this node plus 1, obviously if we are whatever distance from L is 0, it would be from 1, whatever distance of bob from 1 plus 1. So that is reason we are doing this. So distance from bob node plus 1. Now what will happen is, when we will reaching downwards, there would be a condition when this condition would be true, right? So then we would be in bottom up approach, the distance of everyone would be updated, right? So that is why we are going downwards. So now what will happen here is, we are updating the distance from bob SRC, and here in the max child we are taking the maximum value in this way. Now what will happen, we are coming out of this for loop, we are going this, so max value for all the nodes of this SRC we are going, right? And the minimum value. So when we are coming out of this for loop, what we are doing is, now we are checking the timings. So see here, if distance from bob SRC is greater than time, that means Alice is already reached there, because distance of bob SRC is greater than the time. So time is shorter to reach that point. So that means if Alice is already reached there, in that case amount would be as it is. So we are adding the amount directly as it is at the SRC. If the distance from bob of SRC is same equal to time, in that case it is given in the question, we have to divide the amount, divide by 2. Just we did this case, right? When Alice reached from 0 to 1, bob also reached from 3 to 1. So time distance from 1 is 1, and the time is also 1 from Alice to reach here. In that case we were dividing this value 4, right? 4 was divided by 2. So in that case, so for to handle that case we are doing this case. Okay, if distance is equal to the time, we are dividing. And if a distance from bob is smaller than time, in that case what will happen, bob has already opened that node, and if it is already opened, we don't get anything. So that is why we haven't put that in if condition, because we are not getting anything there, we don't get any reward, right? So that is why we are ignoring that condition. Now see here, we are returning this case. So if max child equal to integer dot min value, means if this max child is leaf node, in that case whatever income so far we got, we are returning that value. Otherwise, if it is a non-leaf node, we have to return whatever the sum, max income plus max child so far. So now this util function is being used directly in our solution. See here. So see here, initially 0. So Alice is starting at 0th node. So we have given SRC equal to 0. And SRC is itself parent. So we are giving parent also 0. And 0 is the timing where Alice is starting. And bob is given in the question. Amount is also given in the question. So we are using this util function. So let me execute this code. So I am executing my code. Now let me try to submit it. Yes, so it is 94.44% faster. Now, in this case, the time complexity is O of n and the space complexity also O of n. And the benefit of this approach is we are using DFS only one time. Okay, we are not doing the two-time traversal of the nodes. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.